While MOPS might be a good starting point for motion graphics, it's definitely interesting to combine it with Houdini's built-in dynamic system. Here's how to. So I'm inside of a GeoNode here, and I'll just drop down a Platonic just as an example here, and scale this down a bit. Then use a MOPS instancer to generate some sort of distribution for that, and also add a MOPS randomize to randomize the orientation, just to break this up a bit. So how do I go about bringing these individual instances into a dynamic simulation? Well, first thing I'm going to do is drop down a DOPNet and wire in my MOPS instances into the first point of that DOPNet and highlight it and dive in there. And by default, there's not much in here, except an output node. What I'll use here to solve this system is a rigid body solver that I'll wire into the output. And for this solver to work, I also need dynamics objects. In our case, RBD packed objects. That's what our MOPS primitives, our MOPS instances are. Just wire this in the gray slot in here. And under geometry source, in my RBD packed object node, let's select first context geometry. So this will automatically take care of this input here, always generating the dynamic objects. So when I hit play now, not much happens. That is because there are no forces acting on our individual copies here. So let's add a gravity. And the gravity force, in our case, goes below the rigid body solver. So let's go up one level, hit play again, and I can see now all those instances fall. However, they don't have anything to collide with. And an easy way for this simulation to create something to collide with is in the shelf tools here, go to collisions, make sure your DOPNet is highlighted, and then click on ground plane. And this is one of the things that I dislike a bit about the Houdini shelf tools. They kind of create a distributed network with nodes scattered all over the place. So what we don't need is this ground plane object here. Let's just delete it and head back into our GeoNode where we built the MOPS setup, and also head into our DOPNet here. And we can see Houdini automatically added something. So these few nodes here were our initial simulation that we set up, and Houdini added those here. So on the one hand, that's been a ground plane object, which we can see here, and in here, let's delete the object path here. We got rid of that, and also maybe dial back the position a bit on the y-axis, so we have actually some height for those instances to fall to. Then, if we wanted to have different ground planes or other static objects, we could use this merge here to merge them into the static solver in order to combine different geometries. As we don't like that now, we can also delete that, and that leaves us with this node graph here. And the oftentimes confusing thing when you're starting out with DOPs and DOPNets is you assume that they work in the same way as a SOPNet would, so that the nodes and the connection between those nodes would form an image and a network of how data flows. And that is not really the case. The thing with DOPNets is it's more of an execution graph, in that it tells Houdini in which order to execute those given nodes. And the execution order is always left, right, top, bottom. So in our case, we'd start with the ground plane, the static solver, then into this merge. We can see those two wires leading in there. So first we evaluated the left one, now let's evaluate the right one, and again from the top. So after we executed the static solver, let's execute the RBD packed objects, the rigid body solver, and then the gravity. And then, as there is nothing more to execute here, let's output that. Up one level and hit play again, and we can see now we have this static simulation. And by static, I of course mean dynamic. Let's create another collider by dropping down another Platonic and also moving that down a bit so that it intersects the ground plane, like so. And in the DOPNet here, let's add back that merge node. And also, let's create a static object here and just use the SOP path to point to this Platonic object here and wire it into our merge here. Let's head up one level, hit play again. So that too did work. However, just for the case if you run into these problems of collisions not working or collisions looking wrong, there's a way to fix that in the DOPNet. In the static object or RBD packed object nodes, there's a tab called collisions. And what we're using here is called bullet data. And there is this drop-down menu called geometry representation that currently is set to convex hull. So let's show the guide geometry. And we can see this intersects with my Platonic, so it's doing a good job of building a geometry. However, let's build something a bit more problematic for this default setup by going up and maybe adding a box. Move that down too, and let's scale it a bit, 3 by 3, and then merge this together with the Platonic. and use this merged geometry here as a collider, this thing here. So inside of my DOPNet, let's dive in there. Let's point my static object to my merge node, like this. And now you can see, instead of this box with a protruding platonic, the static object set to convex hull is generating this weird shape here for a collision geometry. And when I hit play, I can see my individual instances reacting to this collision geometry and not to this original geometry that's underlying here. The reason for this is that we chose a convex hull collision geometry, which is easier to solve and quicker in simulation terms, although not as precise. So if you want to have the more precise, more proper solution, set this one to concave. And let's reset the sim. We can see now we don't see any protruding guide geometry or collision geometry. And as soon as we hit play, our instances behave correctly again. So keep that in mind, setting the geometry representation under collisions bullet data, not only for your static objects, but also for your mobs packed instances, again, bullet data and collision representation. Getting these settings right is quickly done and often overlooked, especially when you're starting out using DOPs, so keep them in mind. Also, you can set up the physical behavior of your mobs copies under the physical tab and the physical behavior of your static objects, your colliders, as well under their physical tab here. Okay, let's head up one level, and that is how to do basic dynamic simulations using mobs packed primitives.